Welcome to ETManufacturing Industry Dialogue Series, where we invite industry leaders and experts from technology to discuss on the mega trends in the global industry as well as the Indian manufacturing industry. So today we have with us Dr. Nagahanumaiah, who is the director of Central Manufacturing Technology Institute, that is CMTI, which is a research and development organization under the Ministry of Heavy Industries, Government of India, and that focuses on providing technology solutions to the manufacturing sector and also assisting technological growth in the country. I would like to mention here about CMTI's remarkable journey from a service provider to a technology originator. So this was under the stewardship of Dr. Nagahanumaiah, which stands as a testament to the Institute's boundless potential and its pivotal role in the Institute's trajectory. So he remains a constant source of inspiration, innovation, and leadership in the Institute as well as in the industry, driving the growth of manufacturing technology and the enhancement of workforce skills. So, Doctor, I would like to start with my first question. CMTI has seen a remarkable transformation under your leadership. So, what was your core vision when you took over as the director, and how have you aligned the institute's strategy to realize that vision?
Good afternoon. Thanks for an opportunity. Yeah. Before I joining CMTI, I worked for almost 2 decades in CSIR laboratory, Central Mechanical Engineering Research Laboratory. My knowledge on CMTI before took over as a director, I used CMTI facility few times as a customer. I visited here. Of course, since I born brought up in this place, so naturally CMTI was aware. CMTI is technologically very strong, particularly the machine development. That I was always aware. Was the only the lacuna which which I understood at that time was uh, primarily we focused on providing a service rather than developing a technology. Or even if you develop a technology, we did never encash that. And then when we look at the institute, the vision I set is how to transform this national institute as a technology developer, right? So when you look at a technology developer, can we able to develop machines that are new to India at least? Then the process technology that makes Indian manufacturing competitive, and to license these technology and innovations to the industry so that these developments could be multiplied for the benefit of Indian manufacturing industry. I think that was the major kind of focus when I took over this. Uh, while doing this, it is always journey is a beginning. It is tough. The reason is how to transform this technology, because when I want to transform this institute as a technology developer, naturally the challenge is how to bring the knowledge creation and the revenue creation, right? Both how to bring Saraswati and Lakshmi together. It is always the challenge. But yes, I think we could able to reach there with the focused interactions and believing in the internal strength of my colleagues.
So, coming to your next question, from being a service provider to a technology originator, this is a significant shift for CMTI. So, what were the key challenges in driving this transformation, and how did you overcome them?
The challenge is, say, first, as I already mentioned, knowledge creation and wealth creation or revenue creation. It is two different kind of opposite. We all believe that will never go together, but that is not true. See, being an R&D institute, unless you create a knowledge, so our relevance itself is a question mark, right? Why people look at CMTI? If unless I different from my neighbor or my sister R&D establishments in some aspect, either you do it technology which is cutting edge, so you are the first, or so you do the technology in a different way, which is much affordable or which competitive globally. I think there are different parameters. Uh, what I thought is, I think there are two C's like cooperation and collaboration are the means. So then what I mean is cooperation is working side by side in harmony. This is both within the institute and at the same time outside the institute. We need to cooperate and then collaborate. Collaborate means working together for the common objective. Because technology development is a process. There is no shortcut. And technology development is a collaborative work and teamwork. It never happens, particularly looking at the technology, currently emerging technologies. So invariably, you need mechanical, electrical, electronics, computer science engineers to work together. I think cooperation, collaboration was required both internal and as well as outside with the customer or with other stakeholders. I think that is what I brought. The another approach, which basically I call it as a 5R approach, 5R, that is relook, reskill, research, reason, and regenerate. I think that we followed strictly and routinely because, yes, in a research, everything is important, but at the same time, the research which is done at the bench, laboratory bench, maybe a novel, even I could have published in a good journal, or I could have got a patent, or I earned some recognitions. But doesn't mean that it is a good or the best for the entrepreneur or who is investing on this, right? We need to understand their dynamics, but at the same time, unless you create a novel or the new knowledge, and unless you create the new science, people won't believe you. I think that is what basically I wanted to inculcate amongst the colleagues, research colleagues here. Yes, all are important. You do create knowledge, but unless this knowledge leads to the industry or the end user or it doesn't generate the wealth, then this knowledge will remain in the book. So how to connect this? That is what I think we focused.
I really liked your approach of this 5R. I think that must have paid off in terms of your strategy, in terms of your strategies in CMTI. So you have placed strong emphasis on open innovation. So can you share examples of collaborative initiatives that have had a significant impact on the Indian manufacturing industry?
So according to me, I think I'm there in this manufacturing domain almost last 3 decades. See, one of the important lacuna in our, particularly the technology development, you can call it as a manufacturing technology or any domain, we never believe each other's. And even today, we are trying to find an answer. Technology development is whose responsibility? Is it academia or research institute or the industry? Or no, is it not the job of government? Right? I think the reason was the ecosystem created were created in parallel. More or less, it is like a different verticals. It was not necessary that I have to talk to industry or I have to talk to academia. So similarly, industry, yes, if I have money, I can go and get it done. Why should I bother whether technology developed in the country or not? I think this was kind of a different mindset. But Corona taught us a good lesson. I had seen some of the cases directly. There were industries who largely depend on the import. I will give you one example. There is a guy who makes surgical mask, and the company is established by Chinese technology, and all the 8 lines. And within the company, I think there barely know, the operators know how to load the material, how to take out the product. But in during Corona, so there were already two lines were down. They were not getting support from China because if anything goes wrong remotely, they were connecting to machines and repairing. But when we like it is in India, so he got a huge order from the government because government has decided to distribute surgical masks to frontline workers. Then he wanted to upgrade this. Basically, the line which was already down, he wanted to make it operational, but he was not getting support. Then somehow he reached to me in our CMTI during lockdown. It's a simple problem, but we could solve this problem. I think that is what the kind of lesson they'll understood that what is the dangerous if you really fully depends on the kind of imported technology or somebody else, right? So then I think doing yourself, believing in your internal strength, and importance of training your own manpower. That is, I think people have understood now. At the same time, so no longer the product development or technology development is a luxury because if you take any product, all products are over-engineered product. Really, it is not required. If you can look at a mobile, possibly my generation people will not use even 10% of the features which is built into this our smartphone or iPhones. Do you really require? And is it that okay? The mobile manufacturer is given free of cost? I don't think so, right? So what is required is instead of the cost of a product, now cost of ownership of a product becomes the priority. So cost of ownership will not come unless you collaborate, unless the innovation happens inclusively, right? Because we engineer or a product developer, product designer is always focus on functionalizing and making component as intelligent or built in with as many as features because I always look at this should be different from others. But does it require? It is not necessary in always. So what is now people have realized that yes, innovation more than the cost, it is cost of ownership of a product. Definitely, people will buy a scooter which I can invest maybe 10% extra if I have to go to service center maybe after 6 months instead of going every month. I think that is a kind of approach. And second is there are many things in the sense government. If you look at every ministry has introduced several schemes. One is DBT Bhairac, that is bringing both industry and the innovators the technology which is demonstrated at the lower TRL level. There is a platform is created to upgrade that into a commercially viable product. And if you look at it, DST, they have a technology development board. They also support the technology which is otherwise demonstrated to lower TRL, at least certain TRL like 4, 5. And there is a support both for industry and also the innovators to upgrade this to higher TRLs. Even in our ministry, Ministry of Heavy Industry, we have a scheme, capital goods scheme. Within that scheme, there is a program called Industry Accelerator. Industry Accelerator is to support the industry or to de-risk the industry in terms of technology development. So here they support to the industry for developing machines or equipments which were not made in the country uh, in collaboration with R&D. Say for example, in CMTI we are building 16 machines to 13 industry partners who have contributed only 20% and 80% comes from the government support. I think there are schemes now, uh, both for the research organization, academia, as well as the industry. Uh, don't stop the technology machines or the technology which you have demonstrated at a lower TRL. You consider that as a low hanging fruit and take it to upper TRL. But not isolation. It should be on collaborative. You work together to take this technology into a commercially viable product.
You mentioned about over-engineered products, but
Yeah.
you mentioned you gave the example of the B2C of the
Mm.
mobile phones. But if you consider B2B in the manufacturing industry,
Mm.
do you see that over-engineering still happens in many of the products?
Yes, it happens for two reasons. One reason is we are always striving hard to be different from others, and second is it is like a throw on wall approach, because I funded you, whether it is required or not, I want it. I think that is many times it happens. They may not utilize what is built into this, but since I'm paid you, you have to give. So by the time project initiation, by the and completion, I think a lot of changes happens. It's only because uh, kind of too much ambitious. Many times it is not required, but still we are doing. It is happening even in B2B. That is another one concern of collaborative research. Success of collaborative research largely depends on definition of the problem and trusting each other's capabilities, and then ethical practices. That is another challenge why many of the collaborations will not lead to a success.
With CMTI's focus on areas like, say, nanotechnology or additive manufacturing and also the digital design. So, how do you envision the future roadmap for technology development in these domains?
In the coming days, I think I strongly believe on the opportunity to convergence of multiple technology. Why? If you look at innovative products or innovation process, the characteristics of innovation is like this: the products, the future products, are getting smart, intelligent, and various form factor like multi-scale, micro, nano to micro, even sub-nanometric scale. And also expected that okay, same product is built in with so many functions, that is multifunctional and all. Then if you look at the processes are becoming highly predictive. Best example is the smart manufacturing. So process can be easily predict either by based on the realistic data which you can embed with the sensor, understand the process, and use appropriate numerical and analytical models to predict the process. And machines, as the product life is less comparatively reduced, and product life cycle. So capital goods is one, it is becoming major bottleneck. So that is why now the more focus in engineering of capital goods is, can I have a machine which is multifunctional? I can use this same machine for a various products, if not for all the category, but similar products or family of products. So then machines are to be built in a modular way and then reconfigurable to at least the group of products or family of the products. So then the last one is, when you are looking these all, the major kind of brain behind this is the controllers, because controllers are also getting kind of focus is changed towards having a controller built in modular or adaptive controllers, right? And then people are also looking at, can I have a controller, open source controller, right? So when you look at these different evolution in the coming days in the manufacturing or the product innovation process, so CMT is, whether I like it or not, I have to gear up to catch this. I have to build, no matter whether I do additive manufacturing, I do digital manufacturing, and maybe I will do nanotechnology. This is to fulfill or to meet the customer's requirement. But what is fundamentally as a R&D institute I have to build is how to gear up with these skills. Can I engineer the machines which could be reconfigured with a minimum effort? Or can I have a solutions whether it is a digital solution or analytical solution, so which can basically understood the process in situ. So this kind of technology is there. So CMT, what it does is, while we develop a technology to meet customers' requirement, we give equal importance to understand these technology and convergence of multiple technology, so that we can easily engineer the product or the machines which in our chosen area, so that with a minimum effort. I think that is what we've currently focused. We give a lot of importance to these aspects, uh, in addition to solving a problem.
So, how does CMTI balance fundamental R&D with applied innovation to ensure both cutting-edge development and also at the same time the industry relevance?
The CMT is known for applied research. There is no doubt. We are not so good in basic research, the so-called basic research. But at the same time, I'm the last person to develop a machine or a product just by purchasing from different sources and integrating and testing. I think that is not the focus of CMT, because that even small scale industries could able to do it. What we try to do is that we develop the machines or we develop the product which are designed from first principle. So without giving anything, that means it is no, it is never be a jugaad, so that it could be process could be repeated, because idea is my technology finally is to be licensed to industry. So naturally, industry has to absorb this technology, and it has to be absorbed from SNT base. Strong SNT base is always there. But at the same time, we really not focused on developing the completely new concept. So what we try to do is, for the new concept, we always and we always look at what is done, what is demonstrated elsewhere. Can we take that knowledge and try to build machines or products which are not existing in the country, and to meet specific requirement. Say, for example, last 64 years, this is our 64th year, we have developed almost 500 plus technology. And unlike any our other sister R&D institutes, we have never made a prototype. Rather, we made a machines or the solutions which are industry ready and deployable. But at the same time, we ensure that these have strong the design fundamentals, and all materials, whatever we use, it is tested and meet the standardization is the definitely we design. And that is the reason what we do is, normally when we look at machines, products, anything we want, we always first question ask, what is the benchmark, who is our immediate competitor. So, and at the same time, then what we have within CMTI, and wherever it is not available, gap is not available, can we able to do it? Can we build that capability? If not, so can we knock somebody's door so that we can collaborate with them, take that and build into our system, so that the product which we made is competitive and at the same time affordable to the targeted customer. So that is how we balance. I can say I'm not good in basic research, but at the same time, the equipment, product, deliverable, whatever we do, we won't build only prototype. We build products ready to deploy, and these are built with strong SNT base.
But when you say you don't make the prototype, how do you ensure that whatever technologies or machines you build, these are application specific and ready to use? How do you ensure the compatibility and other features?
Actually, the CMTI, our R&D activity, we have two approaches. One approach is, there is an industry or my customer, they will come with the definition of a problem. That means he is looking for a solution to meet his requirement. It need not be a cutting edge, but it is customized solution. So there, many times problem is already defined by customer. Then we use our own either we similar experience we had in the past, or the experience we had for a different domain, but that could be deployed and we will do. That is one. But other aspect, other vertical is what we do is we identify technology gaps. We scientists study and prepare the that kind of technology gaps in our chosen area, our verticals. Then we go for a funding agency like any government funding agency, either is a line ministry or the scientific departments like DST and all. And we seek funding like any IIT faculties or other researcher establishments. Then we use these projects to build our capacity and as well as the capability, right? These many times, unless there are specific program, say for example, I mentioned capital goods scheme where industry accelerator program, we developed an industry, we are developing a 16 product, but these problems were already defined by our industry partner and he knows the market demand, what works and where is the gap, and he came with the definition of the problem. There we may not have much flexibility, but there are programs which are still it's a prototype in the sense product has to be demonstrated. There will take little flexibility. Sometimes we also engineer the product or the deliverables little over because we wanted to make, and then when we deploy, I think it is a compromise version. Say for example, we built a diamond turning machine. If you look at our diamond turning machine, first machine we made, I won't call it as a diamond, it is a prototype, but it is the best in terms of features and as well as the kind of accuracy level, but it is an over-engineered product. But what we deployed in, say for example, industry, in this case, it was a bark. We installed two machines. So that machine is commercially viable because it's commercially competitive and it was not required for the customer. That is how basically we need to, I will say that it is not first generation prototype, second generation prototype. It is functionally they are different. But yes, the machine which we made first time, it works.
Okay. So you mean once you build the machine, it's ready to use as per the customer requirements and as per the R&D done by you. So there is no need to make a prototype. So that's why test it as per the application.
I think that is where the USP of CMTI is.
Nice. That's great. Yeah. So you have successfully initiated technology marketing and incubation. So what strategies have proven effective in bridging the gap between this lab scale innovation and the industry adoption?
CMTI is always working like, say for example, customer comes to us, then we basically provided a solutions to customer, right? Thereafter, what happened is I did not focus on protecting this technology or encashing this to other applications unless my customers comes back for either second one or improved version one. Mostly this will not be taken it further because of so many constraints. So when I joined, what I thought is my journey started, as I said, I wanted to make or transform the institute as a technology developer rather than just service provider. I wanted to create a technology treasure of CMTI, which is like established in 1962, but our first machine developed by CMTI was December 1965. So since then, can I have every 5 years, or if not every 5 years, every 10 years, CMTI 65, 70, CMTI 70, 75. So can we create a technology treasure? Really, I could not make it. I identified a physical space, took a budgetary offer. I don't want even take my visitors to laboratory. I will just take to technology treasure. So that should depict the capabilities of CMTI. But somehow we could not do it. The reason was we never given importance to that. As an institute, we never given importance to this because you came to me and I provided a solution and you have forgotten, I have also forgotten. So that is how we were doing. Then I created technology marketing department. We call it technology value addition cell. So why? Because a lot of effort goes into that technology development process. which could have potential application in other domain. And at the same time, who knows, maybe some other customer will come back for the same technology with little bit of customization. So we started creating. Then first technology profile I made for 19 technology. Then I made second version 54 technology. Now I have 70 technology, depository of 70 technology. Out of that, maybe around 34 technology developed since I took over, but otherwise earlier there's other technology. So we compiled now. Now we are looking for this technology to transfer to the industries. That is one. And second is, when customer comes to us, we started discussing with them. So, do you require exclusivity of the patenting, even if we fund it fully? And sometimes it may not be required because he is not into that business. He wants solution to meet his requirements. That's all. In that cases, so sometimes we take the technology with us, and some people, what will happen is he doesn't have a complete funding, but it is a promising technology. So what we do is we will also negotiate while the formation stage itself, proposal stage itself. So there we also invest because for the technology. And second, the another approach what we do to take care of this technology incubation and all. Now we started participating in all this fairs, startup meets, and then we try to reach out to engineering colleges, incubations, so that this technology, if not marketing, okay, I may not market, I'm not good in marketing, but at least to showcase that, okay, these capabilities are there. If not meets this requirement, at least this expertise can be utilized to meet your requirement. I think that is how we started technology, basically marketing and upgradation. And now we are asking industries that, okay, you either you take this technology if it is as it is, or you look at, then do the market survey, come back, maybe who knows, my technology may not be, as I already mentioned, that may be best on the lab scale at my bench level. I must have got an award, but that may not meet the requirements. So that is how we are basically started discussing. The overall idea is, now we look at, okay, you develop the technology, meet the customer requirement, and also look around whether this technology could be protected for the future use of same or similar applications, or maybe new application. So a lot of thrust is there on protecting a technology, including even small copyright. We will not miss out. That is how we do. But the reason is very simple. Now people will never believe. First, see, earlier what will happen is you give the machine that meets my requirement. I don't bother. But now it is now difficult. If I ask industry technology licensing, you will say what rights do you have, what you are owning. So that even small scale industry they will ask, because that knowledge is there, and at the same time, unless you protect a technology, you can't say this is technology is reverse, and reverse engineering and all doesn't work. Okay, you can always do reverse engineering, meet your requirement, but you cannot sell it to third party.
It's the more of a partnership approach
Yeah,
with the industry.
that's true.
I think many of the institutes or R&D organizations in India should have this approach in across the sectors, not just in your sector. So, given the rapid evolution of smart manufacturing, which is currently the buzzword in every industry, so how is CMTI shaping its skilling initiatives to meet the future workforce demands in areas like especially the AI or say mechatronics or precision engineering?
I think you must be aware, our Ministry of Heavy Industry, possibly uh, first of few ministries who have initiated this smart manufacturing. In 2017, there is a program called Summer Centers. Summer Centers were created, funding started from that time, uh, to build the capacity and capability of smart manufacturing, particularly focused on manufacturing industry. Uh, this was funded to create such center. After that, there are two more center. These four center were called as a summer center. One at CMTI, another at IISc, The third one is at IIT Delhi, and the fourth one is at Pune, the private sector for C4I4. All these centers structure-wise looks same, but at the same time focus is different depending on the internal strength. Our center, what we have is now we have created a smart factory. This is not a just demo factory; it is production factory. Now industry can visit us, look at what is the meaning of smart factory. Unfortunately, Industry 4 is such a technology, even I won't consider that as a technology. It is the kind of a concept. The concept which was already there, which was executing mostly by lot of human interventions. Now these have been automated to a certain extent that your ICT technology is taken care and which is repeatable and then reproducible, that could be ensured. But what is fundamentally this concept says, you understand what you do based on the data which you acquired from your own resources, and then use ICT technology, digitize, share to the different stakeholder, and do some analysis, predictions, and all. Then take autonomous decision. It may be either automation or some decision making. You make it automatic. I think that is what. So understand your process by acquiring a data, digitizing and sharing a data, doing analytics to automate or to autonomize your uh, action plan in the company. So now what we do is there are several technology. There are okay literature say 9 verticals. There are 14 verticals of smart manufacturing. But if you look at these four fundamental these things, there are several technology at the extract level, and if you go as a deeper, there are several technologies which are available earlier and which are even getting evolved, not fully understood. Say for example, let us take lathe. Somebody wanted to ensure that I should get desired surface finish on my turned rod. Operator, what he knows, operator can only do three and off. He has only three and off controls. He can set feed, speed, and depth of cut. Off is maybe tool height is not aligned to center and all. By switching off machine, you can always do that. But if ask any mechanical engineer what all factors contribute to ensure surface finish on turned part, so somebody who has 5 years shop floor experience, he will list 10 parameters. So then how industries works? Industries always works that okay, there is somebody called Gani or somebody Mishraji, Banerjee, somebody. So if something went wrong, operator calls, okay, he will say, sir, ये तो ऐसे हो रहा है, so chattering हो रहा है. Then he will say, okay, ये जाके check करो, क्या है? I think that dependency was there, but that dependency could be reduced with this technology. If your machine is embedded, integrated with some sensors, collect the data like vibration, data like some vision based, or measuring in situ measurements, and what is set program value and what is actual value, all these things. Then finally you can use AIML and all, compute, so you will understand. So maybe simple word, it gives just an alert. Some tool is broken, okay, there is an alert. And at the same time, little complex words, say for example, we build a diamond turning machine. There, if anything goes wrong, your 0.5 degree temperature is increased. Operator will not realize, but program is gets compensated already. Because in a diamond turning, we get 0.2 nanometer RA value in the just turning operation. So those can be done. So now what we have done, what we did in CMTI center is, so we have built a machine. So somebody wants to build a smart machine, the technology is there. And at the same time, somebody just wanted to look at what is smart factory means. So they can visit our factory and do it. And since we are machine tool builders, we have identified some of the basic components like screw, feed driver, screw, driving system in CNC system, or the how to operate a machine, the training part, right? Or how to dismantle, assemble the part. Those kind of solutions we developed a digital part, right? So it can be used for training a people, or it can be used for improving the redesigning, right? So that way, that is one is there. And at the same time, now the technology dependence of import or somebody who developed elsewhere, that we try to reduce, because affordability is an issue. Because this industry for manufacturing, if you ask me what is the ROI, I don't have an answer, direct answer. So definitely the investor, he will always sign the check if there is a quantified ROI. Unfortunately, quantified ROI comes later. So that is a difficult task. What we try to do this is that, so now you implement it. We have developed a cost-effective solution. Say, for example, you have a machine, just 4,000 rupees, 5,000 rupees, we'll maintain your machine. We'll give you trend. What you do with this, it is up to you. If you don't want to talk to us, you can always use. You will get a beautiful pictures. So that way, we've developed our own 15 such solutions and implemented in a company, small company who has 7-8 machines, one owner, maybe 4-5 operators. And we also implemented a company, leading automotive. I will not take because of secrecy their name, which has about 64 machines. Each machine we are capturing 17 parameters and use all AML based solutions, and then we develop the solution and implemented in fact 3 modules, right? And now even to the company like implementing to defense PSUs, right? Where what we do is defense PSU is with pilot plant we are implementing in their component manufacturing division. While implementing, people getting trained, because right now in industry for smart manufacturing, if you ask, definition of the problem itself is difficult. As I said, ROI is the major challenge. So now you implement it, then they learn, they become educated, and for next solution they will come up with a defined problem. Okay, this is what I'm facing. Do you have a solution? So another best example, say for example, if you go industry 4 and all, it is just buzzword. For a company who is doing a job shop, he has a milling machine. Let us assume now actual cutting time is 35%. He will offer me a coffee if I have a solution. Okay, instead of 35%, I have a solution that makes you actual cutting time is 60%. Now, making 35 to 60 is not that easy, but it is possible if you use this technology. I think that is what we are trying to bring and bring it to the awareness program. We conducted series of awareness program as a part of this program. The phase 1 is over now. We developed 15 technology we implemented, and we have created 8 laboratories, experiential lab, jointly with HL. So all the verticals like starting from robot, cobot, AR, VR, automation lab, controls lab. So that will be used, that are being used basically to impart practice-based learning, right? And these are all test beds are built on open source, so that the trainees can go through this and they can make their own program. That is how we are basically focused on skilling. For industry people, maybe it is less than awareness, but if top management, more of MES aspect. For operator level, how to make machines smart, what are the challenges, where you could attend, what kind of alerts you may envisage by these machines. And even to that extent that there are a lot of data now we can capture through controller itself without doing any instrumentation. Those things we are basically teaching to shop floor people. And for academic school, these 8 laboratory which we created with jointly with MHI and HL. So we are using to impart the short-term training and as well as the long-term training, including internships and finishing school. This is more focus on the skilling.
That's great. So, what are your top for example, top three priorities for CMTI,
Yeah.
if you consider over the next 5 years from now?
Yeah, what I look at 2030, so we have a few set targets with respect to technology. Our three major area which we are going to work is we are in the process of design development of a battery production line which is capable of manufacturing 10,000 lithium-ion battery cells, electrical cells in a shift. So complete, there are about 15 to 16 machines. We wanted to indigenize the complete plant we have to make, design developed by us. And also we wanted to have a CNC controller because still CNC controller, lot of dependencies there. And globally, there are very limited number of supply manufacturers or supply chain. So we wanted to have a kind of, can we have CNC controller indigenized by within the country? So we are already rather we called Bharat CNC. So we wanted to have that is another. The third one is we are a machine tool builder. So naturally semiconductor is the focus domain. If you look at semiconductor right now, 100% import. I know Fab Labs will be created initially, but if really wanted to do something, you need to build a supply chain, not to supply a machine or subsystem, but ancillaries to support these things. So we have identified some of about 8 to machines now. We wanted to design, develop those machines in the country. Uh, this is about three diversification with respect to technology while doing what we do now. Uh, Basically, we wanted to do this. Otherwise, for additive manufacturing, we are already diversified and we built now machine with a built volume of 1 meter cube metal additive manufacturing. That too, this machine built with 90% domestic content. That was the target we achieved now. The last text we displayed. Of course, it is long way. We need to study further before deploying into industry, but machine is already ready. So this is with respect to technology part. And the another is as an institute, where do you stand? We wanted to have build like our target is can we build 10 machines that are new to India annually and 10 patents per annum and at least two products or machines in by 2030 which are new to world. It is a highly ambitious high risk project. And then uh, currently we are serving industry uh, about 3,000 services. This we called laboratory service, otherwise TIC, testing, inspection, calibration. So can we double it? Double it for two purpose. One is my revenue generation will go up, and second is industry gets benefited. I think that is where we focused. In fact, we action already taken. We are augmenting testing laboratories. 8 testing laboratories we are augmenting, and currently in the last 4 years average, if you take our average customers is about 750. So now, if you when I look at 6,000 services, definitely customer will not be double. But what is required is how many customers comes back, repeating customer. So we wanted to enhance that percentage of repeating customer because repeating customers is kind of a recertification for our service because service is not only technical, there are many other aspects. So we wanted to enhance the percentage of recertification service while increasing number of service that we TIC services that we offer.
Right. Fantastic to know your vision for the next 5 years. And I'm sure with that vision getting accomplished, CMTI will reach to the next level. So if you are to, again, adding to that, if you are to envision the ideal Indian manufacturing ecosystem in 2030, for example, so what would it look like and how can institutions like CMTI contribute to making that vision a reality?
Say, for example, 2030 or even in the current trend, India, we are all, as a country, we are striving hard to become a globally manufacturing hub. Okay, question is, how one can become globally manufacturing hub. Okay, you can establish state-of-the-art facility and provide a manufacturing service to industry that definitely generate employment and generate GDP, and you will provide a service to the supply chain, which is otherwise OEMs are globally placed, not in the country. I think that should not be our focus because we as a country matured enough, both SNT as well as financially. What is required is Indian manufacturing. I think that is missing to a large extent. We need to focus on knowledge creation and innovation that leads to domestic IP. I think we are very poor in kind of domestic IP and product origination or technology origination. I think yes, it is good while doing all these things. This was a learning, but now at least we should take little risks. So to focus, this not happens only with 1% or 2%. It is complete ecosystem. We all together as a country should focus. Can we have that IPs created in the country, both the product origination as well as the manufacturing process origination. It may product may be a machine, product may be end use corporate equipment or product. That is a different story. We need to identify and which domain where to do. Say for example, maybe let us look at medical is our priority because we have a customer within the country. So that I think it is not one just parameter CMT can alone can decide. I think overall focus should be no matter what you do, we as a country we need to create a domestic IP. I always look at made in India, made for India was our weakness. I think that is no longer exist. Globally, nobody makes for India. And make in India is a process which has begun, right? So what we need to do is that made in India, but that should not be our target also, because made in India will not bring the any brand value. There is no so-called India brand will come if you focus only on made in India. What is required is originated India, that is the sustainable India, and that helps the country to create a brand India. I think our focus should be creating a brand India. It is applicable to individual, it is applicable to the country, it is applicable to the CMTI. So now our focus is also same. Being a national funded R&D organization, basically we are open to join this journey, right? Yes, my capability is building a machines, engineering capital goods. So now capital goods is the highly expensive system in the manufacturing value chain. So definitely this is the priority area, but at the same time, this is not the end product. Once I made a product, people will forget which machine was used. So because people will remember the car, but the pain goes behind to engineer the car, nobody will appreciate. So that is the domain. But yes, we wanted to do that. As I said earlier, also in 2000 by 2030, can I have two such where we can create a CMT brand? So I think that if we complete ecosystems driven to that, it is a risk taking. I think worth taking this risk. I'm sure India can able to do it because we as a country not really made significant progress with respect to technology origination or product origination. Yes, a lot of things happened with respect to engineering, re-engineering, and customizing, localizing. But now this is the time we need to focus on creating brand India, and that comes only when we focus on originated in India.
You very rightly said that for creating brand India or to take the Indian manufacturing to next level, we need to have the knowledge creation and the innovation and like you said, the domestic IP. So that should be the future, and I'm sure with institutions like CMTI, the Indian manufacturing will leverage those kind of advantages to their efforts to make their presence felt in the global manufacturing landscape. So thanks for your presence in our show, and it was fantastic to interact with you. I really like the interaction because I have been interacting with the industry people and used to talk on how to produce machines. But today I came to know about many things about the technology developments for producing the machines. So great interacting with you. It was pleasure having you in our show, and I really look forward to again interact with you in future. Thank you.